Hi guys, so today we're going to be looking at Chapter 2, Section 1, Transformation of Quadratic Functions. So for a quadratic function, this is a function that can be written in the vertex form. The vertex form is the following equation where we have f of x equaling to a times x minus h to the power 2 plus k. The reason why we like to use the vertex form is because it shows us all the different types of transformations that could be given. It makes it easier to graph. For example, right here, whenever we look at A, that will identify if we have a horizontal or if we have a vertical shrink or stretch. And it could also tell us if we have a reflection on either the x or y axis. So I'll write that down as well, reflection on the x or y axis. And then over here, inside the parentheses, we can always identify if we have a horizontal translation. So if our information or our graph is going to be moving to the left or to the right, we can use whatever information is provided to us inside the parentheses here. We have horizontal translation. And in a sense, we're always going to be looking at H for that information. The other one is the K value. So the value that is on the outside of the x squared, that tells us if we have a vertical translation. And that just tells us if we're moving up or down. Okay, so now that we know what the vertex form is, what I want to do is I want to use the vertex form to describe the transformation of the quadratic function represented by the value of g. So let's start off with number 1 here. It says that we have g of x is equal to x plus 2 to the power of 2. Whenever we have a number inside of the parentheses, we know that that means that it's either going to be moving to the left or to the right. And since it's the plus 2 sign, that means that our translation is going to be moving 2 units to the left. So right here, translation 2 units to the left. Cool. Then in number 2 we have a transformation happening in the inside of the parentheses and also in the outside of the parentheses. So it's telling us here that since we have a -1 inside the parentheses, that means we are doing a translation 1 unit to the right. Translation 1 unit to the right. And then we also have right here a number on the outside of our function, which means that we are also going up 3 units upwards. So 3 units up as well. Cool. For our next one, or number 3, we have negative 1/2 multiplying with x to the power 2. Whenever we have a negative number, we know that means that we have a reflection on the x-axis. So this is a reflection on x. And we also know that because we have a fraction, that means that we're having a vertical shrink. Vertical shrink. And it's by a factor of 1 over 2. By a factor of 1 over 2. Cool. Then in the other one over here, this one's a little bit different where the 2 is multiplying, but it's multiplying in the inside of the parentheses. And so because it's in the inside of the parentheses, that means that we're not going to have a vertical shrink. We actually have a horizontal shrink instead. Horizontal shrink. And this is by factor. And then if you remember, whenever you have horizontal shrinks, because of the fact that we're using the specific word horizontal, that means that instead of having 2, we have to flip it so that instead of being 2 over 1, we have 1 over 2 instead. So it's by a factor of 1 over 2. And on top of that, it's followed up by a translation of 1 unit up. So followed by a translation of being 1 unit up. Done. All right. Next one, writing a transformed quadratic form and identifying the vertex. So right here, let's do an example of using the quadratic form and then identifying what the vertex is. The question here is asking us to let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis. This is also followed by a translation 3 units down of the graph of f of x equaling to x squared. And then we want to write a rule for G and also identify the vertex. So let's start off with step 1. Step 1 is telling us to first create the transformed function. So create the transformed function. So whenever we're starting with a function, we always want to start off with the original one. The original one that we're using here is f of x is equal to x squared. So I'll start off with f of x equaling to x squared. And then in the word problem, it tells us that we're starting off by having a vertical stretch by a factor of 2. Since it's vertical, that means that we are going to be multiplying to the outside of the function. And on top of that, we should be keeping it the same. We don't have to do any flips. So I'm going to multiply 2 with my original function that I have. And then it says later on that we have a reflection on the x-axis. Again, if it's a reflection on the x-axis, I am going to multiply a negative sign to the outside of the function as well. So I get here negative 2x to the power of 2. And then it says here at the end, we are following by a translation of 3 units down, 3 units down the graph of f of x. So if I'm going to do 3 units down on the outside of my function, I just need to subtract 3. Done. And so that will be my new function, and it says that we're graphing it in the function of g, so I'll put g of x is equal to negative 2x squared minus 3. Once I figured out what the transformed function is, now I can actually find out what the vertex is. So step 2 is to find vertex. And the best way to find the vertex is to use the vertex form. So vertex using g of x equaling to a x minus h to the power 2 plus k. If you have that formula, automatically it'll make it so much easier to find out what your vertex is. So right here, all I need to do is get my new function, which is g of x equaling to negative 2x squared minus 3, and then rewriting it in the form of gx equaling to a x minus h squared plus k. So if I were to rewrite in this format, I do see that I have my a already shown, but the thing is that the difference here between the g of x equaling to negative 2x squared minus 3 and the vertex form is that there's more information provided in the parentheses. So I want to do the same thing to this equation here. I want to add more information and I find out what my h is. So to do that, I'm going to rewrite my equation to negative 2 and then x minus a number to the power 2 minus 3. Now, I still want to keep this the same equation, even if we rewrite this. So if I were to create the same equation, I would just add a 0 in there because that wouldn't change my original equation here. If I were to simplify this, you would get here g of x. This turns into negative 2. X minus 0 is just x still, minus 3. And still, that's the same as writing down negative 2x squared minus 3. The only difference now is I have this portion similar to each other, which will help me identify my vertex. So again, underneath, I have my g of x equaling to a x minus h to the power 2 plus k. And from here, I can identify what my h value is and what my k value is. My h here is going to equal to 0, and my k equals to negative 3. And if you know what your h value is and what your k value is, that actually tells you what your vertex is. Because for vertex, to find out what the vertex of a quadratic function is, all you need is your h value and your k value. If you know what that is, then you know what your vertex is. So our vertex here is 0, negative 3. And that would be the end of the following answer. Alright, so the next one is asking us to write a transformed quadratic function. If the example is let the graph of g be a translation 3 units to the right and 2 units up, followed by a reflection of the y-axis in the graph of f of x equaling to x squared minus 5x, and then we're writing a rule for g. Cool. So if I'm going to do this, start off again with your original function, which is f of x equaling to x squared minus 5x. So the first transformation tells us that we have a translation 3 units to the right. I want to do that first. Now, if you notice here, we don't only have one x value, but we also have two x values. So because of that, I still need to do the same transformation as I usually do with both functions, which means that instead of having just x squared minus 5x or having it as x minus 3 to the power 2 minus 5, I also need to transform that other x value to x minus 3. So once I do that, then the next thing that I want to do is to simplify. The important part is that no matter what you get as your transformation, you always want to simplify your answer before starting on with the next transformation. So I'll write it right here. Simplify your function before moving on to the next transformation. The reason why you want to do this is because it'll make your life a lot easier. When you have too many things in your function and it gets a little too complicated, then it makes it more difficult to provide an accurate transformation. So let's simplify this first. We have here x minus 3 to the power 2. X minus 3 to the power 2. And that would be x minus 3 times x minus 3. If I were to multiply those together, we get x squared minus 6x plus 9. Then I could distribute the negative 5, so I get negative 5x plus 15. And that equals to x squared minus 11x plus 24. Done. Okay, next transformation says that we have 2 units going up. So I'm going to take my entire function here and add just a 2 to it. So right here, the next transformation, and I'll put it right here. So we have g of x is equal to x squared minus 11x plus 24. My new transformation is just to add 2 to the entire function. We get 24 plus 2. And again, I'm still going to start off by simplifying my function out first before moving on to my next transformation. So we just get here 26. Done. Okay, the next one says that we're following it up by a reflection on the y-axis of the graph. So if I'm going to follow it up with a y-axis, that means that I'm not multiplying negative 1 to our entire function. I'm only multiplying negative 1 to our x values. So our new graph right here, we have h of x equals to x squared plus 11x plus 26. And then that turns into changing the negative x or positive x values to negative x values. Changing this one to a negative x plus 26. And from here, if I simplified it, I just get x squared minus 11x plus 26. And that would be the final function. Done. So we get here, let's use m of x is equal to x squared minus 11x plus 26. And that would be our final answer. Cool. So hopefully this helped. Good luck.